Hello. Hello everyone. This is our last class for two-port network. So I think I am audible. 1 second. So in previous class what we have studied? We have studied transformer, some transformer related problem, and second we have studied question discussion. Today we have also question discussion. Today we have also question discussion. Okay, so we have today only question discussion. Okay, so this is our question, this is our topic which we have studied, how to calculate y in or z in terms of h parameter, g parameter, y parameter, z parameter. So we have studied a lot. Then we have studied how to calculate z out in terms of z parameter, y parameter, h parameter, g parameter and ABCD parameter. And this is VTH and JTS in terms of z parameter, VTH and JTS in terms of z parameter. When ZL is connected in second port, VTH and ZTH, and when ZL is connected at first port, VTH and ZTH. So VTH and ZTH in this side. So in this side VTH and ZTH, and in this side VTH and ZTH. So we are going to calculate VTH and ZTH in both sides. Okay. So this is a very important question. They will ask in the GATE exam. And then we have studied for relationship between all parameters. What is the relationship between when z parameter, using y parameter, how you calculate z parameter, using h parameter, how you calculate z parameter, using g parameter, how you calculate z parameter, and using ABCD parameter, how you calculate z parameter. Then after where we have studied y parameter, how we calculate y parameter using other parameter, and how we calculate y parameter, h parameter using other parameter, and how we calculate ABCD parameter using other parameter. And then after we have studied symmetrical and reciprocal network, what is symmetrical and what is reciprocal network condition. Then after we have studied T network and pi network, T network z parameter and pi network y parameter. And then after we have studied lattice network, and then after we have studied the series network, shunt network, ABCD parameter, z parameter, y parameter for shunt network, and z parameter, y parameter and t parameter for shunt series network, and series shunt network, y parameter, z parameter and ABCD matrix. Then after we have studied the transformer condition. Then we have studied the T model of transformer, and then after we have studied the series parallel and parallel series condition. And then after how you calculate series parallel parallel series, KVL, KCL, you know that. Then after you have studied the cascade condition, and then after you have studied the network equivalent resistance from port 1 or port 2 of the transformer. So which this form we have studied. We can study, we can write down in this form also the equivalent model of z parameter, the equivalent model of y parameter, equivalent model of h parameter. You can write it down here, and so that you calculate the matrix. So we have one condition, series parallel condition. We will solve some questions regarding series parallel condition. So this is our series condition, because we both have same current. So same current is there. So this is series condition. So this one is our first network, and this one is our second network. Okay. So what is happening here? How you find out series network? This is I1 current. Yes sir. And this is also I1 current, because the current will flow like this. Then after I1 current and leaving I1 current, so here current will be same. So this is series network. Here I2 current and here I2 current, so they are series network. Then after they have one lattice network and one T model. For lattice network and T model, you should know what is lattice model and T model Z parameter. So if you know Z lattice model and T model Z parameter, you can easily calculate the value. So it is very easy to calculate the value. First of all, what is ZA? So you will say ZA is equal to, here ZA is equal to 3 ohm and ZB and ZC is equal to 5 ohm and ZD is equal to 3 ohm. So this one is a they are a symmetrical network. They are symmetrical network. So ZA is equal to, this one is ZA, this one is ZD, and this one is ZB, and this one is ZC. This one is ZB, and this one is ZC. So here ZA is equal to ZD, and ZB is equal to ZC. So they are symmetrical network. They are symmetrical network. Then after we have Z11 and Z22. Why we are calculating Z parameter? Because they have Z parameter, series condition Z parameter will be added. So Z11 Z22 is equal to ZB plus ZA divided by 2. So ZB plus ZA, ZB is 5, ZA is 3, 5 minus 3 divided by 2, it is equal to 1 ohm. And Z12, 5 plus 2, so 4 ohm, sorry, it is 4 ohm. And Z12 and Z21 will be equal to ZB minus ZA divided by 2, so 5 minus 3 divided by 2, it is 1 ohm. So Z1, Z dash is equal to what? It is equal to 4 1 1 4. So this is our Z dash. This is our Z dash. I will check the formula I have applied correct or not. Yes, ZB plus ZA and ZB plus, this one is ZA also. Then we have next T matrix. We have T matrix. So for T matrix, ZA, ZB, ZC is, so for T matrix ZA, ZB, ZC is, so for T matrix ZA is equal to 2 by S, ZB is equal to 2S, and ZC is equal to 2 by S. Yes, sir. So our Z parameter will be equal to, Z11 is equal to ZB plus ZA plus ZB. So our Z double dash matrix is Z1 is equal to ZA plus ZB, so 2 by S plus 2S, and ZB and ZB plus ZC. So this is equal to 4S square, sorry, 2S square plus 2S, 2S square plus 1 divided by S, 2S and 2S square plus 1 divided by S. We know that Z equivalent will be equal to Z dash plus Z double dash. Yes, sir. So we have 4 1 1 1 4, and we have 2 into S square plus S, 1 divided by S, 2S and 2 S square plus 1 divided by S. So these are the points. Then we will add this Z parameter. So what we will get? We will get 4. So 4S. So it is equal to 2 S square plus S plus 1 whole square. S plus 1 whole square. divided by s, and 2s plus 1, 2s plus 1 and 2 s square plus 1, s plus 1 whole square, s plus 1 whole square divided by s. This is our z parameter. So we have calculated z parameter of this network. So it is very easy, just a lengthy process. We have derived this, we have done this in this previous class, so we are not going to do this again. Then they are asking z parameter in terms of with respect to E and F. So for this type of question, series parallel network, what you have to do in z parameter, if series condition is there, in z parameter this side series, then we will go for equivalent model. Or in y network, this side parallel, we go for which network? We go for equivalent network. If this side series and this side parallel, H parameter model, this side parallel, this side series, G parameter model, and for ABCD parameter there is nothing model, so there is no model. So we have to do like this. If series, you know, if series condition, so you can go through this equation, you know everything. So I told you how to find series and parallel condition. If series condition, Z parameter model, parallel condition, Y parameter model, series parallel condition, H parameter model, and parallel series condition, G parameter model. So by using this you can go through. So this is a very good thing which you have to understand. Okay, so this one is series model, so we can go through the parallel network, parallel model, we can go through the parallel model. So what we will do, just we can go through from basic, and we can go through the some advanced simple level also. So we can go through the basic also and tough level also. So from basic I will go, then after I will go for next level. So from basic I will try to solve this. So what I will do, this one is I1, yes sir. So current is same for both network. With respect to AB, this one is I1, this one is V1, yes sir. This one is V1, yes sir. And this one is I2, and this one is V2, yes sir. So we have V1 is equal to Z11 I1 and Z12 I2 and Z21 I1 and Z22 I2. You can go through this with respect to AB. Then with respect to EF, there is V1 dash, yes sir. So for V1 dash there is a voltage, I will apply KVL. So V1 dash will be equal to V1 plus I1 I1 into 1 I1. So V1 dash is equal to V1, we can write this one. So Z11 plus 1 into V1 plus Z12 I1 and Z21 I1 and Z22 I2. So this is our new Z matrix. So here V2 I2 will not change, here I1 will be same, only V dash will change, so V dash will change. So our new Z matrix will be Z11 plus 1, Z12, Z21 plus 1 and Z22. You can go through like this. So this is our new Z matrix. New Z matrix. Okay. We can go through this question also. We can write like this. We can go through the equivalent model also. We can go through the equivalent model also. This is 1 ohm. This is Z11. This is our voltage source, dependent voltage source, plus minus Z12 I2, and this one is Z21 I1, and this one is Z22. So in second port there is nothing changed. In second port there is nothing changed. So what we will do? It is very simple. What we will do? It is very simple. So here current is I1. Here voltage drop is V1. Here current is I1, but voltage drop will change from V1 dash. Here current is I2 and voltage drop is V2. So with respect to V1 dash, Z11 will change. With respect to V1 dash, Z11 will change. Z11 plus 1. Z11 plus 1. So it will be, so Z parameter matrix will be, only Z11 will change. So Z11 plus 1, and we have Z12, Z21 and Z22. So only Z11 will change. So this is a simple equivalent model. There is a question like this also. There is a question like this also. You have to think like this also. There will be question like this also. With respect to this, there is a Z parameter. With respect to this, there is a Z parameter. There is a Z parameter. Z11, Z12, Z21 and Z22. Yes sir, there is a Z parameter, and there is one connection in between them. So in this case there is a connection. There is a connection of voltage source minus plus 2I2. Minus plus 2I2. So there is a connection like this. Yes. And there is a connection like this also. There is a connection like this also. 2 ohm. And they are asking the new Z parameter. They are asking the new Z parameter. So how will you calculate new Z parameter? This one is our V1 dash. I1 is same. This one is I1. And this one is our V2 dash. So V1 and V2 dash will change. This one is V2. This one is V1. And here current I2. Yes sir. So what we will do? First of all, we will go for, I will apply KVL here. I will apply KVL here. What is happening? V1 dash plus 2I2 is equal to V1. So V1 is equal to, V1 dash is equal to V1 minus 2I2. Yes sir. And second, in this case KVL, V2 dash will be equal to, V2 dash will be equal to V2. This is our question. they are asking the solution. So V2 will be equal to V2 plus 2I2. Yes. Then after we can write V1 dash. V1 dash is equal to V1. So Z11 I1 and Z12 I2. So Z12 minus 2 I2 and V2 dash will be equal to Z21 I1 and Z22 2I2. So Z22 plus 2 I2. Yes sir. So our new Z parameter will be Z11, Z12 minus 2, Z21 and Z22 plus 2. So this is our new Z parameter. It is a very simple question. Okay. Series condition you can go through directly, but parallel condition will change the name. Parallel condition will change the question. Next, you can go through the T model also, equivalent model also. You can go through equivalent model also. Minus plus 2I2. This one is Z11. Yes sir. And this one is Z12. Z12 I2. So it will be added in Z12. This will be added in Z12. And there is a voltage model, plus minus. Yes sir. And we have Z21 I1 and this one has Z22. Yes sir. And this one we have 2. So 2 ohm will be added here and they will be added here. So this one will be added in this case and this one will be added in this case. So this one will be added with this one. Yes sir. So our new Z matrix will be Z11 and Z12 plus minus minus plus, so it will be minus 2 and Z21 and Z22 plus 2. You can go through like this. So this is our Z parameter model. So you should have to think like this, then you will go through the question. If you don't think like this, then it will be very difficult to analyze the question. Very difficult to analyze the question. Okay. Then there should be a network like this. So in case of Z parameter, there is a series condition. In case of Y parameter and G parameter, I will tell you. So in case of here series condition and here series condition. If both sides series condition, then if series condition here Z parameter, series condition here Z parameter, both sides series Z parameter. So we can go through the Z parameter. Series condition here, we can go through the H parameter. So series condition in first port, Z parameter or H parameter. Series condition here and this one is parallel condition. Yes sir. In case of Y parameter, this side parallel and this side also parallel. This side is parallel in case of G parameter. This side parallel and this side series. Yes sir. You can go through like this also. So if series condition in first port, there will be Z parameter or H parameter, you can directly add in Z or in H11 or H12, in Z11 or Z12. You can directly add or subtract. In case of parallel, series condition in second port, so you can go through Z parameter or G parameter. You can directly add in Z22 and Z21. In case of parallel in first port, it will be G parameter. So you can add in Y11 or Y12, G11 or G12. And in case of parallel in second port, you can go through H parameter or Y parameter. So you have to think like this. You have to think like this. Then you can solve this question. Let us assume this is a question. They are asking Y parameter. They are asking Y parameter. New Y parameter. Parallel condition, Y parameter will be added. So this is a very easy question. Parallel condition, Y parameter will be added. So Y parameter will be added. So there is a here Y is 0.5 ohm. So 0.5 ohm is 2 per ohm. This is R and this is G. Yes, sir. So our new Y will be added, and Y will be added in Y11. So Y11 plus 2, Y12, Y21 and Y22. Simple. Parallel condition, Y parameter will be added. Series condition, Z parameter will be added, Z or H parameter. So there should be, you should focus on that. Which parameter will be added? Series, Z or H, you can directly add or subtract. In series parallel, you can go through the equivalent model. It will be very easy to solve. If you go through the equivalent model, it is very easy to solve. So this question is solved through equivalent model very easily. This question will be solved through equivalent model very easily. How? This is our 2𝐶1. Yes, sir. And Y parameter model is Y11. Yes, sir. And there is a current source. If you understand this, then there is no problem with that. V2. Now you can directly think like this. This will be added in. This will be added with this one. So Y11 plus 2, Y12, Y21 and Y22. Fast solve. Through equivalent model, you can solve it fast. You can solve this question very fast. Then T network will be given and they are asking, T network is given and they are asking which parameter? They are asking H parameter. T network is given and they are asking ABCD parameter, H parameter. So what you will do? Nothing. First of all, you can go through the ABCD matrix. Yes. So first of all, what you do? First of all, you will calculate ZA, ZB, ZC. So ZA is equal to 2 ohm, ZB is equal to 1 ohm, ZC is equal to 1 ohm. Yes, sir. So Z11, Z matrix will be ZA plus ZB, 2 plus 1, 3, ZB 1, 1 and ZB plus ZC 2. So this is our Z parameter. Then you don't know how to use Z parameter in ABCD parameter. It is very easy to use. So first of all, write it down ABCD parameter. AV2 minus BI2. Why I am writing minus? Because in Z parameter I2 is inward, so I will take inward. And a CV2 minus DI2. Yes, sir. Try to understand. This is our two-port network. Yes, sir. In Z parameter, it is incoming current. In Z parameter, it is incoming current. So in ABCD parameter also it is incoming current. Yes, sir. Then I will make V2 is equal to 0. Short circuit. Yes, sir. Short circuit. So we have V1 is equal to. So V1 is equal to minus BI2. Yes, sir. And I1 is equal to. I1 is equal to minus DI2. Yes, sir. So what we will do? What we will do? Just B is equal to B is equal to V1 minus V1 divided by I2 when V2 is equal to 0. V2 is 0, that means this is short circuit condition, and short circuit condition you have to think Y parameter. So this will be think according to Y parameter. So according to Y parameter, so I2 upon V1 is equal to minus 1 by Y21. Minus 1 by Y21. Yes, very easy. Why I am thinking in with respect to Y parameter? Because this is short circuit condition. So I will think like Y parameter. Then we have D. D is equal to minus I1 upon I2. Yes, sir. Minus I1 upon I2, V2 is equal to 0. Yes, sir. I will think according to Y parameter. So I will think according to Y parameter. So I1 upon V1 and I2 upon V1. Why I am dividing I2 upon V1 and I1 upon V1? Because V2 is 0. V1 is not 0. V2 is 0, but V1 is not 0. Okay. So I will write what it will be, minus. Yes, sir. And I1 upon V1 is Y11. And I2 upon V1 is Y21. Very easy. Then we have I2 is equal to 0. Second case. Second case, I2 is equal to 0. If I2 is equal to 0, then V1 is equal to, then A is equal to V1 by V2. V1 by V2, I2 is equal to 0. I will think according to Z parameter. So V1 upon I1, I2 is 0, I1 is not 0, I2 0. So it will be Z11 upon Z21. Yes, sir. And second case is I2 is equal to 0. So C is equal to I1 upon V2. I1 upon V2 is nothing but Z21. So 1 by Z21. So we have calculated A, B, C, D, everything. Yes, sir. Now I can apply. So our Z parameter will be, three, 1, 1, 2. Yes. A is equal to minus Y by Y21. A or Y, B. A is equal to Y11 upon Y21. A is equal to Z11 upon Z21. Z11 upon Z21. B is equal to minus 1 by Y21. C is equal to 1 by Z21. And D is equal to Y minus 1 by D is equal to Y11 upon Y21. Y11 upon Y21. Y21 will be written as minus Z21. So delta Z upon Z21. And Y11 will be written as Z22. Yes, sir. And Y21 is Z21. So I can write it. I will check this formula is valid or not. This formula is okay or not. So Z11 upon Z21, delta Z upon Z21, 1 by Z21 and Z22 upon Z21. Yes, it is correct. Then what I will do? Nothing. Then I will go through the questions. So our delta Z is, here our delta Z is 3 2 is 6 minus 1 5. Yes, sir. Z11 is equal to 3. Z21 is equal to 1. Okay. Delta Z is 5. Z21 is 1. 1 by 1. Z22 is 2. Z21 is 1. So this one is 3. Unitless. This one is 5. So it is Z parameter. So 5 ohm. this is 1 by Z21, so 1 Simon, and this is Z22, so it is unitless, Simon or per ohm. So this is our ABCD matrix. So ABCD matrix for this network is transmission line matrix is ABCD is 3, 5, 1 and 2. So this is our transmission line matrix. So it is very easy to calculate. First of all, you have to calculate Z parameter. And then Z parameter, then relationship between Z parameter, and then use the formula, you will get the answer. This is very easy. Yes, sir. Then again, there is a question like this. This is a question asked in GATE exam. This is the question was asked in GATE exam, PYQ question. So you can first of all go through the which parameter? Z parameter. So our Z parameter will be Z11 will be ZA plus ZB, so 5 plus J4, 5 plus J4, 2 and 5 minus J4, 2. Yes, sir. So 5 plus J4 plus 2, 7 plus J4. Yes, sir. And Z22 is equal to 5 minus J4 plus 2. So 7 minus J4. And Z12 and Z21 will be equal to Z12 and Z21 will be equal to 2. Yes, sir. Then after our Z matrix will be 7 plus J4, 2, 7 minus J4, and determinant is 7 7 ja 49 plus 16 minus 4. So it will be 12, 49 plus 12. 49 plus 12 is 61. 49 plus 12 is 61. So it is 61. Then we have ABCD matrix A, B, C, D. We have just derived. What we have derived? First is Z11 upon Z21. Z11 upon Z21. Second is 1 by Z21. Third is delta Z by Z21. And fourth is 1 by Z21, delta Z by Z21, and Z22 upon Z21. Z22 upon Z21. This formula is wrong here. B is delta Z by Z21 and C is 1 by Z21. Yes, sir. Z11 upon Z21, Z11 is 7 plus J4 upon Z21 2, delta Z 61 upon 2, and 1 by Z21 1 by 2, and Z22 upon Z21, so J4 divided by 2. So ABCD matrix will be 3.5 minus J2. Second is 31.5, 30.5, and sorry 61. Yes. So 30.5 and 0.5, and this one is 3.5 minus J2. So this is our transmission line matrix. So it is very easy to calculate. It is very easy to calculate. So this is 2 marks question asked in GATE exam. This is 2 marks question asked in GATE exam. Yes, sir. Then we have they are asking Z21. T matrix is given, they are asking Z21. Yes, sir. So how we will calculate Z21? It is very difficult task, but we will calculate. First of all, they are matrix. So transmission line matrix is given. Yes, sir. So what we will do? First of all, we will go through. Transmission line matrix is given. Yes, sir. So we will go through the question. First of all, the transversal and matrix is multiplied. First of all, the transversal and matrix will be multiplied. Yes, sir. So our new transversal and matrix will be multiplication of 1 4 3 2 and multiplication of 1 4 3 2. Yes, sir. So multiplication will be 1 4 3 are 12 13 4 and 4 8 12 12 1 3 and 3 2 are 6 9 and 4 3 are 12 2 2 are 4 16. So this is our ABCD matrix. 1 12 13 4 3 no. Yes, ABC, this one is ABCD matrix. Then Z21 they are asking. They are asking Z21. Z21 they are asking. Okay, no problem with that. So what I will do, first of all I will determine what is Z21. So Z21 is I2 is equal to 0. I2 is equal to 0. Z21 is equal to V1 upon V2 upon I1. V2 upon I1. I2 is equal to 0. Yes, this is the condition here. So what I will do, I will write this equation. So this equation is V1 is equal to 13 V2 minus 12 I2, and this for this one I1 is equal to 9 V2 minus 16 I2. Yes. So what we will do, I2 is equal to 0. Yes, sir. If I2 is equal to 0, V1 is equal to 13 V2 and I1 is equal to 9 V2. So V2 by I1 will be equal to, so Z21 will be equal to V2 by I1. I2 is equal to 0, so it will be V2 upon I1 is equal to 1 by 9, and it is in ohm. So 1 by 9 ohm. 1 by 9 ohm. I will check what is V2 upon I1. What is V2 upon I1? What is Z21 in terms of ABCD parameter? 1 by C. Yes. Then they are asking equivalent model. So they are asking Z equivalent. What you will do? Nothing, just simply solve. You will solve this question. First of all, you should know what is Z11 and what is Z22. Then you can calculate easily. So this is our Z22 for first one, and this is our Z11 for first one. Why? This one is open circuit. This one is open circuit. First port is open circuit. Output impedance is Z22. Second port is open circuit. Input impedance is Z11. So Z11 and Z22 in terms of ABCD parameter, if you know the formula, you can easily calculate. So Z11 and Z22 in terms of ABCD parameter, it will be A by C and D by C. A by C and D by C. So Z22 is D by C. So D2 by C2. And Z11 is A1 by C1. Then it is very easy to calculate. So Y in is equal to Y equivalent is equal to, so Z equivalent will be equal to, they are in parallel. So they are in parallel, so it will be, they are in parallel. So for parallel condition, it will be D2 by C2 and A1 by C1 plus D2 by C2 plus A1 by C1. Yes sir. So D2, A1 D2, I have written wrong. So this one is D1 by C1 and this one is A2 by C2. So D1 by C1 and A2 by C2. A2 by C2. Second one is D1 by C1 plus A2 by C2. Yes. Then what you will do? D1 A2. Then there is a two-port network condition is D1 A2, D1 C2 plus A2 C1. This is our Z equivalent. So it is very easy to calculate Z equivalent. It is very easy to calculate Z equivalent. They are asking Z equivalent. They are asking Z equivalent. So here open circuit. Yes sir. Open circuit. So our Z2 is equal to Z1 is equal to, I will write Z1. So Z1 is equal to Z22. Yes sir. And here short circuit. So Z2 is equal to 1 by short circuit Y11 dash. Y11 dash is equal to delta Z dash upon Z22. Yes sir. They are in parallel. So Z equivalent will be equal to Z22 into delta Z dash divided by Z22 dash, and this one is Z22 plus delta Z dash divided by Z22 dash. So Z22 dash will be cancelled out. Z22 into delta Z dash divided by Z22 dash plus delta Z dash. So this is our Z equivalent. Very easy. Just you can think open circuit, short circuit. Done. Open circuit, short circuit. Done. Then we have a network like this also. Then we have a network like this also. What we have a network? We have a network like this also. What we have? This one is our Y parameter. Y parameter is given. What they have given? 1, minus 0.5, minus 0.5 and 0.25. And this one is also 0.25. Yes. So this is our Y parameter, and there is a connection like this also. This one is 0.5. Y parameter is given. They are asking equivalent Y parameter. They are asking equivalent Y parameter. So Y parameter. They are asking Y parameter. So this is in parallel condition. You have to think like this. This is in parallel condition. So this is parallel condition of network connection. This one is parallel condition of network connection. So we have V2. Yes sir. We have V1. Yes sir. So how do you know that this is parallel condition? You can think like this. This is V2. Yes sir. So for this potential is, this one is, I will consider 0 and 0. So for this one is V1. So across this V1, in this network V1, this network V2. So across this V2, and this node has V2. So they have common node of 0 potential. Yes sir. So you can think like this, they are in common condition. They are in common condition. So what we will do, just we will find out. So first, top one is nothing but this is a shunt network, series network. Yes sir. This is a series network, 0.5. So here YA is open circuit. So YA is 0. YB is 0.5 and YC is 0 open circuit. So our Y parameter will be, so Y dash will be equal to, we can go through 0, YA plus YB 0.5, yes sir, minus YB 0.5, minus YB 0.5 and YA plus YB 0.5 and Y double dash, it is given in the question, so we don't have to think like this. 0.25 minus 0.5 minus 0.5 and 0.5. So they are in parallel condition, so Y parameter will be added. So Y dash plus Y double dash, it will be equal to 0.75 and minus 1 and 0.75, and it is per ohm. It is very easy to calculate. Then we have Z parameter, ABCD matrix they are asking. Then we have ABCD matrix they are asking. Yes. So what you will do for this ABCD matrix, for this ABCD matrix, for this ABCD matrix, and for this ABCD matrix. If you know the ABCD matrix, you can calculate very easily. So Z is equal to, so ABCD matrix will be equal to, for series what is ABCD matrix, for shunt what is ABCD matrix, for Z parameter what is ABCD matrix. So in GATE exam they will ask like this. So for series we have studied, so what is series ABCD matrix? Series ABCD matrix is 1Z01, 1Z01, yes sir. So for series is 1Z01, 1Z01 and this one is a 1Z01 series. Then after, for this one, for shunt network ABCD matrix will be, so for shunt network ABCD matrix will be 1, 0, 1 by Z1, 1, 0, 1 by Z1, and for this ABCD matrix will be, so ABCD will be equal to A3, I will write A3, B3, C3 and D3, yes sir. So this one is Z11 upon Z21, delta Z upon Z21, 1 by Z21 and Z22 upon Z21, yes sir. I think this is the formula. Just I have used this formula, so I will use this delta Z Z22, okay. So what is the answer? So for Z11 upon Z21, Z11 is minus 1 and Z21 is 1, so minus 1. Delta Z 2 minus 1 minus 3, so minus 2 minus 1 minus 3, so minus 3 upon Z21 1, Z22 2, yes sir. So it is minus 1, B3 is minus 3, 1 and 2. You will multiply, you will get ABCD matrix. You will multiply this, you will get ABCD matrix. So this is a very simple question. So today our two-port network discussion is over. So I will come with some other topic after some time. So this is question discussion session of two-port network. Today the completion of two-port network. Thank you. You can join my group for any confusion, any doubt. Sonu sir PW. You will get the PDF in PW app. Thank you. Thank you everyone.